Hi, welcome back to Smart Civil Engineering. This is the second video in our foundation series. In today's video, we're going to learn about strip foundations and raft foundations, which both belong to the shallow foundation category. Let's start with a strip foundation. A strip foundation is another type of shallow foundation. Compared with a pad footing, it is slightly more complex and usually a little more expensive. You can think of it as the next step up from a pad footing because it provides continuous support instead of supporting individual columns separately. So when do we use a strip foundation? Load-bearing wall needs to be constructed. Columns are closely spaced, making individual pad footings overlap or come very close to one another. Constructing low-rise buildings, where pad footings alone are not sufficient to safely transfer the structural load to the ground. Now let's understand the concept. A strip foundation works in a very similar way to a pad footing. The main difference is that instead of supporting one column at a time, it forms one continuous reinforced concrete footing along a line. This continuous strip spreads the structural load evenly over a larger area of soil, reducing the pressure on the ground and improving the stability of the structure. For load-bearing walls, whether they are constructed using reinforced concrete, brick masonry, or random rubble masonry, strip foundations can be designed according to the amount of load being transferred to the soil. For relatively light loads, a random rubble foundation may be adequate and economical. However, when the wall carries heavier loads, a random rubble foundation may become either structurally unsuitable or more expensive due to the increased width and depth required. In these situations, a reinforced concrete strip foundation becomes the better and more reliable solution. Another common application is when columns are placed very close together. Imagine constructing separate pad footings beneath each column. As the spacing between the columns decreases, the individual footings begin to overlap or become too close to one another. This creates inefficient load transfer and can lead to construction difficulties. Instead of casting several overlapping pad footings, engineers combine them into a single continuous strip foundation. This provides a more uniform distribution of loads, reduces unnecessary concrete, simplifies construction, and often results in a more economical foundation system. Strip foundations are widely used for single-story, two-story, and medium-sized residential or commercial buildings, provided the soil has sufficient bearing capacity. Now let's look at the advantages of strip foundations. First, they are much more economical than deep foundation systems such as piles, because they require less excavation and no specialized construction equipment. Second, the construction method is relatively simple and can be completed using conventional site equipment. Third, they provide excellent load distribution, spreading the structural load continuously along the entire length of the wall or row of columns. They are ideal for low-rise buildings, where the structural loads are moderate and the soil has good bearing capacity. Construction is also faster because excavation, reinforcement fixing, formwork, and concreting can be carried out continuously along the trench. Another advantage is that future extensions to the building are generally easier to connect with existing strip foundations compared to isolated pad footings. In addition, strip foundations require less maintenance, provide good structural stability, and perform very well when built on soils with uniform bearing capacity. Now let's briefly see how a strip foundation is constructed. The process begins by setting out the building and excavating a continuous trench to the required width and depth specified in the structural drawings. After excavation, the bottom of the trench is leveled and compacted. A layer of lean concrete, also known as blinding concrete, is then placed. This creates a clean, level working surface, protects the reinforcement from soil contamination, and helps maintain the required concrete cover. Next, the reinforcement is placed continuously throughout the strip, according to the structural engineer's design. If reinforced concrete columns or reinforced masonry walls are part of the structure, their starter bars are fixed at this stage. After the reinforcement is inspected and approved, the necessary formwork is installed where required. Concrete is then poured continuously, properly compacted using vibrators to eliminate air pockets, and finally cured for the specified period to achieve its required strength and durability. Like every foundation type, strip foundations also have some limitations. They are not suitable for weak or highly compressible soils, where excessive settlement may occur. They are generally unsuitable in areas with high groundwater levels, unless proper dewatering and waterproofing measures are implemented during construction. They cannot support very heavy structural loads as efficiently as raft foundations or pile foundations. Finally, strip foundations require reasonably uniform soil-bearing capacity along their entire length. If one section of the soil is significantly weaker than another, differential settlement may occur, which can cause cracks in walls, uneven floors, and even structural instability. One of the most important considerations when selecting a strip foundation is not only the building load, but also the condition of the supporting soil. Even if the structural load is within acceptable limits, the soil beneath the entire strip must have a relatively uniform bearing capacity. Since a strip foundation is continuous, any weak zone beneath it may settle more than the surrounding areas, creating differential settlement that can seriously affect the performance of the entire building. Finally, regarding the dimensions of a strip foundation, there is no standard size that fits every project. The width, depth, reinforcement, and concrete grade are determined through structural design carried out by a qualified structural engineer. The design is based on several factors, including the building loads, soil-bearing capacity, number of stories, wall or column arrangement, groundwater conditions, and any additional loads such as wind or seismic effects where applicable. A strip foundation is a continuous shallow foundation used mainly for load-bearing walls and closely spaced columns, where isolated pad footings become impractical. It distributes structural loads evenly over a larger area of soil, making it an economical, stable, and efficient foundation system for low-rise buildings with good ground conditions. Although it offers many advantages, including simple construction, excellent load distribution, lower cost, and faster construction, it should only be used where the soil has adequate and uniform bearing capacity. Remember, selecting the correct foundation type is one of the most important decisions in any construction project, because every load from the building is ultimately transferred safely to the ground through the foundation. Now let's talk about the raft foundation. A raft foundation, also known as a mat foundation, is the most advanced and generally the most expensive type of shallow foundation. However, it is also one of the strongest and most reliable shallow foundation systems, capable of supporting large buildings on soils where other shallow foundations may not be suitable. You can think of a raft foundation as the final step in the shallow foundation category. To understand it easily, let's compare it with the other foundation types we've already discussed. A pad footing supports a single column. A strip foundation combines several footings in one direction to support a continuous wall or a row of closely spaced columns. A raft foundation goes one step further. It combines the footings in both directions, creating one large reinforced concrete slab that supports the entire building. In most cases, the raft foundation covers almost the entire footprint of the building. In some projects, the raft may even extend slightly beyond the building outline to improve load distribution. Instead of transferring loads through individual footings, the entire structure rests on one continuous reinforced concrete slab. This allows the building loads to spread over a much larger area, significantly reducing the pressure applied to the soil. There are four main types of raft foundations. The first type is the flat plate raft foundation. This is the simplest form of raft foundation. It consists of a reinforced concrete slab with a uniform thickness throughout. There are no beams beneath the slab, making it similar in appearance to a flat slab used in suspended floors. This type is suitable for light to moderate structural loads, where the soil has reasonable bearing capacity and the column spacing is relatively small. Because of its simple reinforcement arrangement and formwork, it is the easiest and quickest raft foundation to construct. The second type is the beam and slab raft foundation. This type looks like an upside-down floor slab. It consists of a reinforced concrete slab combined with beams running between the columns. These beams increase the stiffness of the foundation and help resist bending caused by heavier structural loads. Beam and slab rafts are commonly used for medium to high-rise buildings, where a flat plate raft alone cannot safely carry the structural loads. The third type is the cellular raft foundation, also called the box raft foundation. This foundation consists of top and bottom reinforced concrete slabs connected by internal walls, creating hollow box-like compartments. These internal cells significantly increase the stiffness of the foundation, while reducing its overall weight compared to a solid concrete section of the same depth. Because of its exceptional rigidity, this type is suitable for very heavy buildings, industrial structures, and locations where settlement must be kept to an absolute minimum. The final type is the piled raft foundation. As the name suggests, this foundation combines both a raft foundation and pile foundations. Here, the raft carries part of the building load, while the piles transfer the remaining load to deeper, stronger soil layers. This system is used when the surface soil is too weak to support the building by a raft foundation alone. Sometimes, the required raft area becomes larger than the available building footprint, making a conventional raft impractical. Instead of increasing the raft size indefinitely, engineers introduce piles beneath the raft. The structural load is then shared between the raft and the piles, creating a highly efficient foundation system for large buildings constructed on weak ground. Where are raft foundations used? Raft foundations are commonly used in several situations. The first is where the soil has low bearing capacity. If the ground cannot safely support isolated pad or strip footings, a raft foundation spreads the load over a much larger area, reducing soil pressure. The second application is for buildings with many closely spaced columns. Instead of constructing dozens of overlapping pad footings, engineers design one continuous raft foundation, making construction more practical and economical. Raft foundations are also ideal for heavy structures, including apartment buildings, hotels, hospitals, shopping complexes, office buildings, schools, and industrial facilities. Another major advantage is their ability to reduce differential settlement. Even when soil conditions vary slightly across the site, the raft behaves as one rigid slab, distributing the loads more evenly and minimizing uneven settlement. They are also widely used for basement construction. In many modern buildings, the raft foundation also serves as the basement floor slab, reducing construction time and eliminating the need for separate footings beneath the basement. Now let's look at some of the major advantages. The biggest advantage is its excellent load distribution. Since the entire building rests on one continuous slab, structural loads are spread evenly over a very large area, greatly reducing soil pressure. Raft foundations are also highly suitable for weak soils, where isolated footings would experience excessive settlement. They significantly reduce differential settlement, helping the building settle more uniformly and reducing the likelihood of structural cracks. For large buildings requiring numerous footings, a raft foundation can actually become more economical than constructing many separate pad or strip foundations. In many cases, it can even eliminate the need for much more expensive pile foundations. Because all columns are connected by one reinforced concrete slab, the overall structural stability of the building is greatly improved. Construction is generally much faster than installing deep pile foundations, since only one large excavation is required and no specialized piling equipment is needed. Another important advantage is that raft foundations provide excellent resistance against uplift pressures, making them particularly suitable for basement structures where groundwater pressure is present. Now let's briefly look at how a raft foundation is constructed. The process begins with setting out the building according to the approved structural drawings. Next, the entire building footprint is excavated to the required foundation level. Once excavation is complete, the exposed soil is carefully leveled and compacted to achieve the required bearing capacity. If weak pockets of soil are discovered, they must be removed and replaced with suitable engineered fill. After ground preparation, a layer of lean concrete, also called blinding concrete, is placed. This provides a clean and level working surface, prevents soil contamination of the structural concrete, and helps maintain the required reinforcement cover. If the building includes a basement or groundwater is expected, a waterproof membrane is installed over the blinding concrete before reinforcement begins. The reinforcement is then fixed according to the structural drawings. This usually includes bottom reinforcement, top reinforcement, beam reinforcement where applicable, column starter bars, and additional reinforcement around heavily loaded columns. After reinforcement inspection, the edge formwork is installed. Concrete is then poured continuously over the entire raft. Because raft foundations are very large, engineers carefully plan the concrete pour to avoid cold joints. Mechanical vibrators are used throughout the pouring process to ensure proper compaction and eliminate air voids. Once concreting is complete, the foundation is cured for the specified period to achieve the required strength and durability. Although raft foundations offer many advantages, they also have some limitations. They require large quantities of concrete and reinforcement, making the initial construction cost higher than pad or strip foundations. They require careful planning, experienced supervision, and high-quality workmanship, because construction errors are difficult and expensive to repair after concreting. Raft foundations may not be economical for small buildings constructed on strong soil, where isolated footings can provide the same performance at a much lower cost. Waterproofing becomes extremely important when the groundwater level is high, especially for basement structures. Finally, when the soil is extremely weak or highly compressible, even a raft foundation may not be sufficient, and engineers may need to adopt a piled raft or a full pile foundation instead. Structural design considerations. The dimensions of a raft foundation are never selected by experience or guesswork. Every raft foundation must be designed by a qualified structural engineer based on detailed engineering calculations. The design depends on several important factors, including the total dead load and live load of the building, the number of stories, the column spacing and structural layout, soil-bearing capacity obtained from a geotechnical investigation, settlement analysis and allowable differential settlement, groundwater level and drainage conditions, wind loads and seismic loads where applicable, concrete strength and reinforcement grade, punching shear around heavily loaded columns, bending moments, shear forces, and deflection of the raft slab, applicable structural design codes such as BS 8110, Eurocode, ACI, or local standards. These factors determine the raft thickness, beam sizes, reinforcement arrangement, concrete grade, and the overall foundation dimensions. So let's quickly summarize today's lesson. A raft foundation, also known as a mat foundation, is a large reinforced concrete slab that supports the entire building as one continuous unit. It is commonly used where the soil has low bearing capacity, where columns are closely spaced, where heavy structural loads need to be supported, or where a basement is incorporated into the building. Although raft foundations require more concrete, reinforcement, and careful engineering than other shallow foundation types, they provide excellent load distribution, high structural stability, and reduced differential settlement, making them one of the most reliable foundation systems for modern construction. As with every foundation type, selecting a raft foundation should always be based on a proper geotechnical investigation and structural design. A well-designed foundation is the key to ensuring the safety, durability, and long-term performance of the entire building. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe to Smart Civil Engineering for more practical civil engineering lessons. I'll see you in the next video.